6.1, operation of functions. So we're given the functions f of x equals 2x and g of x equals negative 4x plus 5. They want us to do these operations. So let's do them. f of x plus g of x, this when we add these two, so 2x plus negative 4x plus 5. And that'll get me, at like terms, negative 2x plus 5. Domain and range. Remember, domains, at this point, we need to, everything's all real numbers unless you're dividing. Right? So what could you not plug in? In this case, I could plug in everything, so all real numbers. I'll be fancy about it. There we go. F of x times g of x. So 2x, I'm going to times it by negative 4x plus 5. Let's distribute, and I get negative 8x squared plus 10x. Domain, again, no fraction, so all real numbers. F of g of x, we're going to plug g into f. So I always ask myself, what is this guy? What's f? F is this. F is 2 times something. Now we're going to plug g into it, and g is this guy, negative 4x plus 5. Then we distribute, so negative 8x plus 10. And again, no fraction, no denominator, so all real numbers. Next, we want to subtract them. So f of x minus g of x. Now keep in mind it's f of x minus g of x, so it's that minus g of x. Key thing here is parentheses, so you have to strip the negative. A lot of people forget the parentheses and they always subtract this guy, not both of them. So put a parenthesis, this is f of x minus g of x. Distribute 2x plus 4x and then minus 5. Add like terms, 6x minus 5. Domain, all real numbers. Next one, f of x divided by g of x. So f of x is 2x, g of x is negative 4x plus 5. And that's it. That's all I can do there. Nothing reduces. I cannot reduce these two because remember, this is together. It's like a parenthesis here. But what is interesting is the domain. It's not all real numbers anymore. We have a fraction. And the fraction, when you have a fraction, the denominator can't equal 0. So in this case, it's a little confusing. There you go. Negative 4x plus 5 cannot equal 0. You can't divide by 0. So then you just solve it. Subtract 5. Divide by negative 4. X cannot equal 5/4. If I plug 5/4 into this, I'm going to get 0 on the bottom. You can't divide by 0. So that's my domain. X cannot equal 5/4. You can be anything you want. Every other number is good except for 5/4. G of f of x. So same thing as before. What is g? In case we weren't sure, I showed it to you. G is negative 4 times something plus 5. That's an ugly parenthesis. So that's what g is. What is f? F is 2x, so let's plug 2x in. Then we just gotta simplify. Multiply these together, negative 8x plus 5. So notice how these two are not the same answer. F of g of x and g of f of x, totally different. Not totally, but different. And then my domain, well, I don't have a fraction like I had here, so all real numbers. There we go. So that's the second one. For this set, now I have f of x equals x squared and g of x equals negative x plus 1. Same idea. So add them first. So x squared plus negative x plus 1. That's it. Can't do anything. All real numbers. Multiply them. So x squared times negative x plus 1. Distribute. Negative x cubed plus x squared. That's it. My domain. There's again no fraction. All real numbers. No matter what you plug in, you're going to be fine. F of g of x. So again, I always start with this part. What is f? What's the outside? So f is something like this. F is something squared. Then let's plug g in. G, because we're plugging g into f, g is negative x plus 1. So I do have to simplify this. Don't give me x squared plus 1. It's not right. Don't just square both of them. It doesn't work. When you see a square here, you're going to multiply it by itself. Negative x. So I get x squared minus x plus 1. So I get x squared minus 2x plus 1. My domain, there's no fraction there, so all real numbers. Right? So very different than if you just square both of them. If you just square both, you get x squared plus 1. You miss this part, so it's the wrong answer. F of x minus g of x. The key thing here that I said before, parentheses. You have x squared minus parentheses negative x plus 1, distribute x squared plus x minus 1. Domain, all real numbers. F over g, f is x squared, g is negative x plus 1, there we go. Domain, the bottom cannot equal 0 because it is a fraction, and you can't divide by 0. I'm just going to add the x over, that's the easiest way of doing this. I was about to do other things, but let's just add the x. So 1 equals x, or actually 1 cannot equal x, my mistake. That's your domain. So you can be any number, plug in the number you want it there, except for 1. 1 is bad in this problem. G of f of x, we're going to plug f of x into g. So again, this time, what is g? G is negative x plus 1. So negative something plus 1. That's what g is. Now let's plug f in. F is x squared. So negative x squared plus 1. Domain, all real numbers. So there we go. Next one. In a particular county, the population of the two largest cities can be modeled by f of x equals 200x plus 25, and g of x equals 175x minus 15. Works for the number of years since 2000, population is in thousands. What is the population of two cities combined after a number of years? So this wants to add the two functions. That's all they're asking. You're saying, hey, what's f of x plus g of x? So we just go 200x plus 25 plus 175x minus 15 and like terms, and there we go. What's the difference population of two cities? So now they want to subtract. So f minus g of x, so 200x plus 25 minus parentheses to important x minus 15. And technically I should probably put it here and here, but this is the one that matters, right? When minus sign has that parentheses back here. Distribute the negative, so negative 175x plus 25, 15, 200x plus 25. Add like terms, so that's just 25x plus 40. And there we go. So that's how you use an application problem. The next one, they want us to find values. So h of g of 2. So there's two ways to do this. I'm going to do the way we probably know it more. So we're going to plug g into h. Alright, so what is h? H is this guy. Oh. H is... Okay. I'm not going to do that way because that way sucks. So the easiest way of doing when there's a number there is you want to do this guy first. So first find what g of 2 is. So we're plugging 2 into g. So negative 2 times 2 plus 1. So negative 4 plus 1 equals negative 3. Right, once you get that, this part's done. That's just 3. So now what we got to find is plug 3 into h. And whatever this is, it'll be our answer. So 9 plus 18 plus 8. So 26, so 35. That's the answer. Right, so you plug the inside in first, get an answer for that, and now that's what this number, that's what this value equals, so it's just h of that value, negative 35. Well, what I was about to do was, you could plug g, you could figure out, you could do what you did here. Read from the notes, right? You could do this, and then plug in your number, but a lot of times that's more difficult. So this is much easier, just plug into the first one and get your answer plugged into the second one. So same thing here. We find g of negative 2 first. So negative 2 times negative 2 plus 1. So 4 plus 1, that is 5. And then we're going to find f of 5. So plug 5 into f. You get that. So that's our answer, 25. So the thing works when there's a variable there. F of g of 3a. We're going to do the exact same thing. We'll do 3a first. We'll plug 3a into g. So I'm plugging everything to g first, aren't I? So that's going to be negative 2 times 3a plus 1. So I get negative 6a plus 1. That's what this is. This is negative 6a plus 1. And now we're going to plug that into f. F of negative 6a plus 1. F is 5 times whatever. So distribute, I get negative 30a plus 5. There we go. Next one. So what if we do this, like the most complicated version of this stuff? f of x equals x plus 2, g of x equals negative 4x plus 3, h of x equals this. Find the value of each. So they want to do f plus g times h with the value of 1 inside. So I think the easiest way to do it is kind of set this up first. Don't like some file away, but set it up. So what's f plus g? In parentheses, so that would be x plus 2 plus g negative 4x plus 3. Then I gotta times that by h, which is x squared minus 2x plus 1. And then I want to plug 1 in. So I'm not going to do anything with the 1 right now, but I'm going to plug 1 in eventually. So what you don't want to do is try to simplify away. This takes way too long. You can simplify a little bit. So I get negative 3x plus 5 times x squared minus 2x plus 1. Now if you want, you could simplify, but this takes way too long. What you want to do here is, okay, I got to sufficient simplification. Now just plug 1 in. Right, once you get there, just plug this guy in. So plug in 1 here, here, here. So up here I get negative 3 plus 5 times 1 squared minus 2 plus 1. So this would be 2 times 0. Yeah, 0. So I just get 0. Right? It's so much easier that way. So when it's something ugly and long like that, just simplify it to make it a little bit easier, and then you go, okay, let me just plug 1 in instead of multiplying this all out. So for the next one here, you got f of g of h of 2. So you could do the same thing, simplify a little bit, or you just do what we did before. Do this first. What is h of 2? Plug 2 into h, so 2 is going to be 2 squared minus 2 times 2 plus 1, so 4 minus 4 plus 1. We just get 1. So this part's done. That's just a value of 1. And then we work our way back. So now let's do g of 1. So that's going to be negative 4 times 1 plus 3. So now I got negative 1. So this part's all done. That's negative 1 now. So now we do f of negative 1. Just work our way all the way back. So negative 1 plus 2. And we get 1 after all of that. So that's the way it works. So if you have a lot of f of g of stuff, just work your way back. G of x. Now this one I can't do that because there's no value. So I just literally got to plug g into g. So what is g? G is this, negative 4 times something plus 3, right? Like that's what g is. And we're going to plug g into it. So then you can tell yourself, what's g? Well, g is the same thing, negative 4x plus 3. So inception. Then we distribute, and I get negative positive 16x minus 12 plus 3. So 16x minus 9. That would be my answer. Okay, the last one here, g of f of x equals 3. So this one's a little different. You're not plugging 3 into f. It's a separate equation. It's saying f of g of x equals 3. So let's figure out what f of g of x is. We're going to plug f into g. So what is g? This guy. Then we're going to plug f in. F is this guy, x plus 2. And all that should equal 3. And then I can just solve it. Negative 4x minus 8 plus 3 equals 3. Negative 4x minus 5 equals 3. Plus 5 plus 5. Negative 4x equals 8. Divided by negative 4. X equals negative 2. And there we go. We're done with the worksheet.